Okay, at question 6, they say the passenger of a car see the turn-off between two signs is 100 meters, and it says it takes 3.5 seconds to pass them. And we want the velocity or the speed. It's 100 divided by 3.5, and that gives you what, Niakalo? What did you get? Then why do you not trust yourself? Yes. Sorry? Don't round off. 2 decimals. 2 decimals. Yes, Carabello? Okay, so they say an ambulance can drive an average of 50 kilometers per hour in traffic. The accident is 7 kilometers away. How long does it take him to reach the accident? Courtney, what did you do?
Oh, I said V equals D over T, and then I said D would be 50, which will equal to 7 over the time, and then U times, and then you get 7, 14.
Time is underneath the fraction, so you want it at the top, and then that 50 goes to the bottom. So 7 divided by 50. And that gives you 0.14 hours. Do we work in hours? We work in seconds. Okay, so first if we take it to minutes, you times by 60, and then you get 8.4 minutes. And if you times that by 60 again, you get 504 seconds. Does anyone do first aid in this class? First aid is those people that next to the rugby field when you play a game, you do first aid, or you know about it. Okay, right, 504 seconds. Is that a long time? If someone were in an accident and you need to resuscitate them? You need to do that where you push on them? CPR. Yes.
I did not do the swapping thing. I just got straight from T equals 7 over 50.
You need to start with a formula. Did you write down a formula? Then you lose a mark. Okay. Right, and next one, question 8. They ask there, how far, so they want the distance, will a car travel in 30 seconds if its speed is 18 meters per second. Remember, you start with the formula. And then again, I'm just going to show this. X is now above the fraction. We want him there, so we keep it there. So the 30, we need to get that away. How do we do that? You multiply by 30, or you take it to the other side, or whatever you call that in mathematics. So you're going to type in 30 times 18. And what do you get on now? No, oh, sorry. Come on. 540 meters. Wait. Ona, it asks, does a speed trap measure a car's instantaneous speed or its average speed? Instantaneous. It measures the speed at that small time frame. Okay, then question 10, they ask you to convert the following kilometers per hour to meters per second. Khali, when we convert it, do we multiply or divide by 3.6? From kilometers per hour to meters per second. You divide by 3.6. Okay, for the first one, Hope, what do you get? Next one, Arelo.
22,22
Sorry, 22.
22,22 meters per second.
And last one, Retabile.
33,33 meters per second.
Good. Yes.
At the first one, if your answer is 16,66.
Because it's 16.66666666. You need to round off to 2 decimals. So what does that 6 do to that 6? Makes it a 7. Never. Never, ever, ever. Your first chapter, we did 2 decimals. Okay. I didn't give you question 11. Okay, let's quickly do that together. Yes, Ronnie? No. Where's yours? Regabile, will you just share with him today so that he can see, please? Okay, it says there, a person walks 60 meters east and then 60 meters north and then 60 meters west. Okay, so I'm saying again, it says 60 meters east, 60 meters north, 60 meters west. And they say all of that takes 120 seconds. Moving quite fast. Okay, now the first question at 11a, they ask you to draw a sketch of his journey. Okay, now here we did draw a sketch of his journey. I didn't ask for I didn't ask graphically. I didn't ask to scale. So that is why I do not have a scale. That is why I didn't measure it off 6 centimeters, 6 centimeters, or 3 or whatever. Okay? This thing is also called a vector diagram. And they love to ask a question like this in a test or an exam. A vector diagram. Okay, because we have vectors. What is a vector? It's a line and an arrow. The length of the line tells you the size, and the arrow tells you the direction. Okay, now question B, they ask you, what is his distance traveled? Cloney. 180 what? Meters. No direction needed because distance is a scalar. A scalar only has size. Then they ask at question C, calculate his average speed. Bukamuso. Average speed. What are you going to say? What formula are you going to start with? Wait. His distance, we just said is 180, and his time is 120 seconds. Okay? They ask here for his speed. Speed is a scalar that is linked to the distance. Okay, so we have 180, 120, that's 120. And what do you get, Sepo? $1.5 what? Wait. You do not have to give a direction because it is a scalar. Then at question D, they ask you, what is his velocity? Now, velocity is a vector, and velocity is linked to displacement. So, Kutlwano, what is his displacement for that scenario? Wait, because it's a direct line between your start and your finish. It's 60 meters, but not just 60 meters, 60 meters north. Okay? So his displacement is 60 meters north. Now we're going to go get his velocity. So his displacement was 60 meters north. The time is still 120. Because to get from his start to his finish still took him 120 seconds. So that is 0.5. 60 divided by 120. And what do you get? Well, yeah. What is it? 20. 6 divided by 12. Nee man, Kutlano. It's a half. 0.5 meters per second. But remember, it is a vector. A vector needs to have direction as well. So since his displacement was north, his velocity will also be north. They are linked, they are the same. Okay, sharp. Back to your notes. Okay, we were busy with that scenario of your house, you're walking to the shop, and then you walk back to school. And that all happens in 5 minutes. And then I asked, calculate the boy's average speed for the journey, and we said speed is linked to distance. So we looked 800 meters plus 400 meters gives you 1,200, and 5 minutes we took to 300 seconds. So you got 4 meters per second. Okay, now if we ask what is his velocity, velocity is linked to his displacement. So yeah, what is the boy's displacement for the scenario? Wait, 400 meters? Say again? Yeah, give me the direction. East. Because he started there and then he ended there. So he walked 400 meters east. How do I know it's 400? Because that there is 800 and that there is 400. So the difference is 400. So his displacement is 400 meters east. So to get his velocity, his displacement 400, and the time is still 300 seconds. Because to go from his start to his finish took him 300 seconds. And that gives you what, Carabello? In your head. 4 divided by 3 gives you what? How many times does 3 go into 4?
1.
And then what do you have left? Yes? So how do you say that in a decimals?
0.5.
3, 3, 3, 3, 3, 3, 3. Okay, and since this is east, this direction will also be east.
In writing this answer, can we just say
A capital E.
Yeah.
Okay, next one they say, Wade van die Kerk, you all know who that is?
Yes.
Do you know this man? You should have seen him in the newspapers. Okay, he practices with Usain Bolt, yes, or he did. Okay, so Wade van die Kerk is, he was Olympic champion of South Africa in the 400 meters. Okay, so he is a very, very, very fast guy. There he is with his world record of 43.03 seconds for the 400 meters. That is insane. 400 meters. Okay, right. So it says there, Wade van die Kerk runs the 400 meters at an average speed of 9.3 meters per second. How tall is the door again? 2 meters. So 9.3 seconds is 3.5 doors. Just quickly stack the doors on top of one another. 3 and another one. In 1 second, he covers that distance. Okay, so he is very fast. And now we ask, how long does it take him to complete his race? Okay, so let's check. The distance that he travels is 400 meters in an average speed of 9.3 meters per second. And we want to know how long does that take him. Sora, have you answered something? Not yet. Okay, go. Here. Okay, what did you type in? So remember, the t is at the bottom of the fraction. We don't want it there. So we take it to the top. And the 9.3 goes to the bottom. So you type in 400 divided by 9.3. And sorry, say again, you got? 43.0. If you have, Ronnie, what is x? Then why don't you do it here? But it's a different question. Yes.
If that comma 01 was like comma 00, we don't have to write comma 00.
How fast is? My father. My father. 4 days. Arabella, I'm not an athlete, ne? I am faster than now. That we have concluded that. Okay, right. Next one, acceleration. All right. Now we proved or we showed acceleration with actually me and Muhal running, and we said acceleration is actually how fast are you going faster. Okay. So the definition there for acceleration is the rate at which velocity changes in size, and I want you to write here and or direction. Okay, so the rate, just take the whole box and send it because I know he's going to want some. I know he's going to want some. Okay. Where are we? Yeah, Carlo. If you hear the word rate, what must you think of? What is the rate at which the attendees come to class? So what are you thinking of? You're thinking about time, specifically. Slow, it takes a long time. Fast. So, whenever you hear the word rate, from now on until you die the day, you must think about divide by time. Okay, so rate is divide by time. So let's read this definition again. Acceleration is the rate, divided by time, at which velocity changes. So what must we divide by time? We must divide velocity by time. Velocity. Okay? But not just velocity, at which velocity changes. Courtney, what is the symbol for change again in science? Delta. The triangle. And that means delta, you're going to look at the final minus the initial. Kamu, what does the word initial mean? Initial. Just let me spell it for you. So, initial. No, not the... No, not initials, not your initials.
The initial velocity, the primary. The main. If I'm right, I must just
Una, let us hear. Hey, shh.
I find later and unfound, and that's it.
Okay, for later is initials, and the second the description onvangs. 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 Kamu is going to tell us what does that mean. Onvangs. Yes, let me hear. Ew. Nee, wacht. Kamu.
First at the beginning, like first letter of a person's name.
So first or at the beginning. So the word initial means at the beginning. First. The first one.
Those parsings of origin.
Okay. Right, so let's just check. I said delta is the change in, means final minus initial, or the last one minus the first one. Okay, so the rate divided by time at which velocity changes, so the change in velocity. Okay, now, Khali, what do we measure velocity in? The unit for velocity? Meters per second. And the unit for time, Hope? The unit for time. Say again. It's written on there. Seconds. Okay. Now you remember that whole thing where we took this thing up? Now we're going to take another one up. So now we have meters per second per second. Meters per second. And now I took that second up. So it again becomes second minus 1.
So it becomes split seconds. So milliseconds.
Not split seconds. No, not milli. Meters per second squared. Yes. The per means negative. That's what we wrote down here. No, this one. Alright. So acceleration is the rate at which velocity changes, and that is measured in meters per second squared. Okay, so here I wrote on the right hand side, acceleration is in meters per second squared, and because velocity is a vector, acceleration is also a vector. Okay, then the change in velocity always means the final one minus the initial one. Final minus initial, or you can write it as the change in velocity. Okay. Right, then if acceleration is positive, then it means the velocity increases, meaning it goes faster and faster and faster. Always say we speak about positive acceleration. Positive acceleration. Are you writing this down, Bukamuso? I can see that. Where's your notes? Do you own notes? I want to see them the next period, and that will be tomorrow. First period. Right. Then, if your answer is negative, acceleration is negative, then it means the velocity decreases or the object is slowing down. It goes slower. And then we speak about deceleration. Deceleration. Something decelerates, something goes slower. It's like your capacity to take in new information decelerates from second break. Ne? Then your brain cuts out. Yes?
If negative is deceleration, then why can't positive be acceleration?
It is acceleration.
Acceleration. Without
I don't know. I am not a language teacher. Okay, here we're back to Wade van die Kerk. Okay, it says Wade van die Kerk takes 3 seconds to reach a velocity of 12 meters per second. Okay, so it takes 3 seconds to reach a velocity of 12 meters per second from the start. Calculate his acceleration. Okay, Hope, did you answer something?
Yes,
What did you answer?
10.
It's true.
Yes.
She did. Relo, that 12 meters per second, what symbol goes with that? What information did they give us there?
the initial velocity.
Okay, let's read the question together. It says, Wade van die Kerk takes 3 seconds to reach a velocity of 12. the final velocity. So, Ritabile, what in the world will his initial velocity be? What does the word initial mean again? The first. No, 3 is seconds. So ask calculate his acceleration. Say again? Somewhere there is information between the lines. What is his initial velocity? And I'm going to show you to give you a clue. He's running a race, ne? With funny cat. On your marks. Get set. Go. What is his initial velocity? Zero. He stops from race. He's not moving. Aha. Okay. So that information, they will not necessarily give it to you. You must know in a race, they start from race. Okay. So let's look. Acceleration is a change in velocity over the change in time, or you can write down final velocity minus initial velocity over time. Okay, the final velocity was 12, the initial velocity is 0. Please fill in that 0. They want to see it. And the time is 3 seconds. Cloney without a calculator. No, you can. 12 minus 0 is what? 12 divided by 3 gives you what? 4 meters per second squared. Now, because it is a positive answer, it means it's accelerating faster, 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 faster. So you can just say acceleration, or you can say in the positive direction, or you can say forward. No. Wait, funny car is not a car. Okay. Next one, they ask. A car accelerates from 72 kilometers per hour to 180 kilometers per hour in 6 seconds. Calculate its acceleration. Bukamuso. What is the car's initial velocity?
0.
No.
6.
Is 6 seconds a velocity? So what is initial velocity? Okay. Right? So what is the car's initial velocity? 72 kilometers per hour. Do we work in kilometers per hour? No, we need to take it to meters per second. How are you going to do that? By?
Divide by 3.6.
You can thank your friend Cloney there next to you. Tepo. Final velocity? Final velocity? 180. And again, you need to divide by 3.6. And when you do that, you get what? 50. Really? Okay. So, acceleration is final velocity minus initial velocity over time. The final velocity is 50. Initial is 20. The time is 6. And can you do it in your head? Good, Luano. What is it?
5, 7, 6.
Okay. Wow, they asked. To avoid an accident, a cyclist brakes and reduces her speed from 28 meters per second to 4 meters per second in 4 seconds. Calculate her acceleration. Give me her initial velocity. 28. Her final velocity, Sia? 4. And her time, Carabello? No, her time. Her time. 4. And what do you get, Zora? In your head. -6. Okay, now what does the negative mean? Decelerate, slowing down. To avoid an accident, she slows down. So it should be negative. But in science, we never leave our answer in the negative. Never, never, never. So you're going to say, this means 6 meters per second squared deceleration. Okay, never allowed to leave your answer in the negative. So you write it into a positive and then you give the direction with it. Or you can say negative acceleration. Or you can say in the negative direction. Direction. Yeah? That is how they wanted the end of matric. Yes?
Using deceleration with double C.
No, I don't think so. We can ask our dictionary ladies to look it up for us. What say I?
She will look for you.
All right. Okay, so grade 10s. I'm going to give you homework now, but because the periods are so long, yeah, you can finish your homework now. Then tomorrow, I'm going to explain your practical. That will be for marks. Okay? So tomorrow, I'm going to explain it to you. So your practical will be from page 8 until page 10. Okay? Your practical will be, so I'm going to explain that tomorrow. Then Wednesday, you're going to do your practical in groups. And then I don't see you Thursday. And then on Friday, you're going to write your test on your practical. Okay, all counts for marks. All right, so your homework now is on page 20. That worksheet on acceleration 1, 2, 3, 4. And you can finish it now. I'm also going to write down the memo now and I'm going to show it to you in 10 minutes. Acceleration. Deceleration. Yeah, and that's what I wrote. Time to be happy. What did you do?
It's attempt to be happy.